I'm going to show you how gas reacts with vinegar and baking soda. So this is how you do it. This paper towel is filled with baking soda. And in the bottle is filled with vinegar. So you put the paper towel inside that's filled with baking soda. You close it up real tight. You shake it up until it's really, really tight. As you can see, nothing happened right now. So it still needs to be shaken up. Close it a little tightly. Close it up. No, as you can see, this is what happens when you put vinegar and baking soda together. It makes a big old explosion. An explosion you just saw. Yes, it was a gas explosion. The particles moving very fastly as usual, which made the bottle tighter and they had more pressure, which made the bottle explode as you've seen in the past. Now we'll be talking about gases and their properties. Gas particles are relatively far apart from each other and are able to move easily past each other, which makes it easy to flow, and this is called a fluid. The speed and the amount of times a gas molecule collides against each other determines either if it goes up or down. If the molecules collide more frequently and go fast into the surface, then the pressure is going to rise. The molecules collide once in a while and more slowly, then the pressure is going to lower. The random motion of molecules causes gases to diffuse, and it moves from a region of high concentration to low concentration. The molecules moving more frequently quickly mix with the molecules as gases in the air. Boyle's law is the law that states that for a mixed amount of gases at a constant temperature, the volume of the gas increases and the pressure of the gas decreases. And the volume of the gas decreases as the pressure of the gas increases. On Charles' law, the law that states that for a fixed amount of gas at a constant pressure, the volume of the gas increases as the temperature of the gas increases, and the volume of the gas decreases as the temperature of the gas decreases also. Gay-Lussac's law is the law that states that the pressure of a gas at a constant volume is directly proportional to the absolute temperature. Avogadro's law, the law that states that equal volumes of gases at the same temperature and pressure contain equal number of molecules. The standard temperature and pressure for a gas, the temperature of 0 degrees Celsius and the pressure of 1.00 atmosphere. To convert Celsius to Kelvin, you subtract negative 73 to any certain amount of degrees Kelvin. And to turn Kelvin to Celsius, you add 273 to any amount of degrees Celsius. 0 Kelvin is the highest and the stopping point of freezing. So that's the lowest temperature can go. Now I'm going to tell you two definitions, temperature and volume. Temperature is a measure of how hot or cold something is, and measure the average kinetic energy of the particles in an object. Volume is a measure of the size of a body or region in three-dimensional space.
Today we're talking about acids and bases.
That was
and observable properties of acids in liquids would be tart, sour, and sharp taste. Acids all have in common that they contain dissolved compounds and which are acids. Bases are mostly solid, are slippery to the touch, and have a bitter taste. Acids are donators of protons and bases are acceptors. Strong acids and bases fully dissociate with water, and weak acids and bases dissociate partially. On a pH scale of 0 to 14, 0 to 6 is very acidic. 7 is neutral, and 8 to 14 is basic. The strongest an acid can get to is 0, and the strongest a base can get to is 14. That's the strongest it can get. Here we have an example of acids: oranges, lemons, and lime. Over here you can see bases: soap and ammonia. Ammonia is a more stronger base than soap. So there, and if you look up here in this tree over here, there are a lot of lemons, which is very acidic.
And
that will be all for
talking
today.
about chemical equilibrium. And as you see, the Charles principle is a system at equilibrium that is disturbed. The system adjusts in a way to reduce the change. For example, if you're in a loud noise, you might want to move to a quieter area. The chemical equilibrium consists of 3 kinds: a change in concentration of reactants or products, and a change in temperature, and a change in pressure. Now, Juan, are you paying attention? Here we have an example. See, first we had 50% of paint and 25% of ammonia. If we add 25% more of ammonia, the system it's equal to each other. So now, that's all for chemical equilibrium.